Hi everybody, Mr. Martineau here, Cranston High School West, and accompanying me, Ms. Mangarelli on the phone. Hello there.
Hello.
Today we're going to start a brand new unit. The unit is on waves. It's an interesting to do this unit because waves are a way that you can transfer energy from one place to the next. So we saw that in the plate tectonics, or we saw that in the earthquakes. Earthquakes are the result of a wave or energy going from one place to another through the earth. So a wave in general is anything that oscillates or vibrates back and forth or goes back and forth. So there are a lot of things that we could say have wave-like motion. So for instance, a water wave crashing into the ocean or a water wave in a wave pool is obviously a wave, and you know what it looks like. Sound wave is a wave. If you play guitar, you know that strings vibrate or oscillate or make waves back and forth. A pendulum clock. Grandfather clock that swings back and forth. You could call that a wave because it oscillates. It moves back and forth, left and right and back and forth. There are plenty of things that we could call waves, but today we just want to talk about generally what are the parts of a wave and how do we classify waves. So that's what we're going to do right now. So I'm going to take the phone.
Okay.
Thank you much.
You're welcome.
So here we have a representation of a wave. So I'm going to be moving my phone in here so we can get different parts of it. One thing we want to note is that waves transfer energy. So the way that energy, we did conservation of energy and we said, well, it's transferred or transformed. Well, how does energy get transferred? You don't put energy in the energy car and drive it over from one block to the next. The way that energy gets transferred is by way of a wave. And that's how all energy is transferred in one way or another. We can look at a wave in terms of its displacement up and down, or its displacement left and right. So once again, this is the x-axis of my graph. This is the y-axis of my graph. Now you might be looking at this right now and wondering, wow, that's a lot of writing and he's moving back and forth. We have scanned this picture. It is in the stream.
It's going to be.
It's going to be in the assignments. Yeah, it'll be in the assignments. So don't worry about that. We're not asking you to recreate it right now. You will get a copy of this. So here's, in general, this can be any kind of wave. So let's go to one of the things that we might know. Some waves have a maximum value and they have a minimum value. So the maximum height of a wave is called the crest. So that's the highest point of a wave above the x-axis. Remember, the horizontal line here is the x-axis. A trough, T-R-O-U-G-H, so it's not T-R-O-F-F. I get that a lot. A trough is the lowest point of a wave below the x-axis. So a wave has its maximum point at a crest and a minimum point at a trough. So if you're a surfer, you surf the crest. If you're a pig, you eat out of the trough. That's generally how that works. Next we have is a quantity called the amplitude. The amplitude is the distance from the midpoint to the trough. So from here to the trough, or the amplitude is the distance from the midpoint to the crest. Amplitude is just another way of saying the size of the wave. So one example I like to give two examples actually, is if you play guitar and you play electric guitar, you plug your guitar into an amplifier. And what that does is it takes the sound of your guitar and just makes it louder. Before you plug it in, you can barely hear your electric guitar. But after you plug it in and turn up the volume, you've turned up the amplitude of that wave and now it's a lot louder. The other way I like to look at it is if you plug in your guitar into an amplifier and you hit some notes on your guitar, but then you plug it into your amplifier and hit the same notes, you get the same notes, but it's just louder. So amplitude is kind of like wave size, but it doesn't change the amplitude itself. One way I like to look at it is, I'm me and I'll always be me. If I put on some COVID weight, I'll be a bigger version of me. I've increased my amplitude, but I'm still me. So the thing that makes up Mr. Martineau is still me, but I might be a little bit bigger. I've increased my amplitude. And the same thing that goes with waves, right? So you can kind of think of that in terms of sound waves. As sound waves get louder, increase their amplitude, you don't change the tones, you don't change the pitch, it's just louder. So that's all it is, just a bigger version of that wave. The next most important part is wavelength. So wavelength is the distance from crest to crest, or it's also the distance from trough to trough. So wavelength is from here to here, or there to there, okay? And that's going to be one wavelength. Wavelength, what do you think the units of wavelength are in? What do we measure wavelength in? Well, the word length is right there. So we're going to be measuring wavelength in meters. It's also going to have a goofy symbol that you're going to see in the book. It's called lambda. It's a Greek letter that you're going to see later. Another important note on this picture of this wave is that one full vibration or one full back and forth of the wave we would call one cycle. So if the wave starts here, it's going to get to its maximum point, it's going to go to its minimum point, and it's going to end back where it started. And we would call that, here we go, thank you.
You're welcome.
That is one cycle of that wave. If we chose to look at this is the starting point, then it's going to go from maximum to minimum, back to maximum. That would be one cycle. Let's do it over there.
I'll do it over here.
That would also be one cycle of the wave. So if I'm looking at this diagram, let's count the cycles. One cycle, two cycles, and 2 3/4 cycles.
Yeah.
Okay, so it's important to know, and what makes one full cycle is going to be wherever you decide you're going to start from. So if you start from here, that's one full cycle. If you start from here, this is one full cycle. If you think that's confusing, that's okay. We're going to get used to it. But a cycle is basically says, I'm going to end up where I started. So if you run track and you start at the starting point and you run all the way around and you come back to the starting point, you have one full cycle of that track. One last note is that waves transfer energy. That's a big thing because it's the only way that energy can get from one place to the next, because realize that energy is change. Is there anything else?
I don't think so.
Okay. So anyway, that's me. I'm going to get back to my arrow. So that was our introduction to waves. We haven't even talked about different types of waves. We just said these are waves and these are their parts. Please read the sections in the book. Please do all the forms. That is not our cat. He just comes by and says hi. I don't know. Please make note of the book. Please do all the calculations. We are here Monday through Friday, 9 to 2 every day. If you have any questions, concerns, or comments, please let us know. He's still saying hi.
I'm sorry.
That's okay. And that's all. So good luck, everybody, and we'll see you soon. Thanks.